In a facility plant, a production line, what's the difference between actual output, capacity, and system efficiency? Okay, so let's start with capacity. Capacity is the maximum we could obtain from a system. Okay, bearing in mind the following: scrap rate is 0, there is no scrap, all the time is available for production or for servicing. So capacity is a maximum you could obtain from a system. Okay, if it is one person or one machine, this is the maximum you could obtain from this machine or the person. Again, if you're working the full time, there's zero distraction, you're familiar with the job, and the scrap rate is 0. So you're not wasting any time or you're not throwing away any unit. So this is the capacity. If there is more than one unit in the system, as you would see here in this example, so the system capacity, this is, for example, this is the units per day. So 10 units per day, 16 units per day. Each machine on its own, its capacity is 10, 16, 13, okay, 8, 12, if it's on its own. If it's combined with other machine, therefore the capacity would be, this example, okay, is capacity, system capacity is 8 units per day. Okay, because 8 is a bottleneck of the system. What's meant by bottleneck is the slowest part of the system. The bottleneck, it usually dictates the speed of the system. Is the slowest person as a system, the slowest step. Even if you're faster before and after it, you're obliged to work at this speed. You're obliged to work at this speed, otherwise you'll have an issue with the system. So the bottleneck is a speed, is a step that dictates the speed of the system. Therefore, the bottleneck, which is 8 units per day, it dictates the speed of the system, as the system capacity will become 8 units per day. However, the actual output in this case is 5. In the example we have in front of us, we have the actual output of a system, because they want to satisfy demand, or this is how much they're producing, is 5 units per day. Okay, therefore the system efficiency in this case is 5 divided by 8. Okay, this is the system efficiency. But I need to tell you a few things. The actual output, you measure it with respect to the available time per day. So if you have 8 hours per day, this won't be the available time. If you have 1 hour break, okay, 1 hour meeting, therefore 6 hours will be the available time per day. And I need to remind you, the system capacity is on the 8 hours per day. It always consider all the time is available. There is zero scrap. There is zero issue with the system. You're only focusing on the available remaining time per day, okay, in order to calculate the actual output. In a way, like if you want to produce unit of you running the system, you only focus on the available time per day to produce this amount of unit, as you would see here in this example, which is equal to 5. Okay, so we're gonna consider another example. So we have in this example, we have we have 3 operation in a sequence, but does not matter which lace is mill or is used, as you see here, anyone will do. Okay, each lace is capable of handling 30 fittings per hour. Each mill can handle 45 per hour. Here 30 mills per hour or fittings. Okay, and the grinder machine can handle 80 per hour, as 80 units per hour. A different operator run each group of machine, and due to the workload, the lace operator can handle an output of 25 fitting per hour from each lace when they are all operating. But in case they are all running in parallel, this will go down to 25 units per hour. Okay. However, the mill and the grinder machine, they could operate at the same number. So it's 45 times 2 and 80 times 1. Okay. The question is, during the past 40 hours, actual production from this department was 1000 fitting. Okay. Find the system capacity and system efficiency. So we need to calculate the system capacity and system efficiency. So if we start with the system capacity, so we have the system capacity is equal to, we have 75 units per hour for the lace, here 90 units per hour, and here we have 80 units per hour. So the system capacity, as we said before, it is the slowest part of the system, which is a bottleneck. So this is the system capacity. Okay, all right. And we have the actual production from this department is 1000. So the actual output is 1000 units per 40 hours, which is equal to 25 units per hour. Okay, so the efficiency of the system is equal to 25 units per hour as actual output divided by 75 units per hour is 1/3, or 33% busy and 67% idle. So I need to remind you what's happening here of all the terminology we saw so far. Okay, so we have first bottleneck. Bottleneck is the slowest step of the system, or the slowest person. It dictates the speed of the system. So the speed of the bottleneck would be equal to the system capacity or the speed of the system. This is the first point. System capacity is about how much you can obtain from a system, the maximum you could obtain if the scrap is 0 and everything is available as timing. This is step 2. Step 3, actual output, is how much you're producing. Okay, maybe you're satisfying a demand, a customer demand. There is several scenarios you would consider. Okay, this is step 3. I need as well to remind you of efficiency. Efficiency is actual output on maximum you can produce as a capacity. Okay, so here in this example we have 3 lathe machines working in parallel, 2 mills and 1 grinder machine working in parallel. But do we need all those machines, yes or no? So in this example here we have 1 operator in charge of those 3 machines, we have one operator in charge of those 2 mills, and we have 1 operator in charge of this machine. So as we could see, we're only producing 1000 units per 40 hours, 25 units per hour. So we don't actually need to run all the 3 machines here, not even all the 2 machines here. It's enough to run only 1 machine here, 1 machine here, and 1 machine here in order to obtain the system, as you would see here. For if we run like the 3 machines on the lathe, we could come up with 75 units per hour, but all what we need to produce is 25 units per hour. If we run 1 single machine on the lathe, this output will be to 30. This machine could run at 30 units per hour, and the same for the mill and the grinder machine. So therefore we only need 3 machines on all the line. Okay, if we have 3 machines on all the line, the new system capacity will be 25 units per hour divided by 30 units per hour. Okay, so it will be 25 divided by 30. Okay, and the utilization of the system will come up with 83%. In case we run 1 lathe, 1 mill, 1 grinder. The system capacity in this case will be 30 mills because we're running 1 lathe. 2 mills, we don't need them, we only need 1, and 1 grinder machine, so it will be the bottleneck, which is 30 mills per hour.